Hi everyone, welcome back to chemistry. In this video, we're going to use what we learned about acids and bases to learn about acid-base neutralization reactions. Acids can react with metals to produce salt and hydrogen gas. I would urge you to think about if we did a reaction in lab with metal and produced anything like that in lab. So think about that. Acids can also react with bases to produce salt and water. They can also react with bicarbonate and carbonate ions to produce carbon dioxide gas. But in this video, we're really going to focus on this acid-base reaction where they produce salt and water. So just like in a combustion reaction, our products can clue us into the fact that we have a combustion reaction because we'll get CO2 and water. In acid-base reactions, what can clue us into the fact that we have an acid-base reaction is that we're producing a salt and water. And that salt doesn't have to be NaCl. Okay, salt is actually any ionic compound that does not have H plus as the cation or OH minus as the anion. Because if that was the case, those would be acids or bases. Okay, so in an acid-base reaction, a neutralization reaction, we react our acids and bases and we get out salt and water. Some kind of salt and water, not NaCl always, but sometimes. Okay, so when acids and hydroxides react together, acids and bases, we get what's called a neutralization reaction. And in a neutralization reaction, the acid reacts with the base to produce salt and water. The salt that's formed is the anion from the acid and the cation from the base. So what type of reaction is this? Is it combination? Double displacement, single displacement, decomposition. Yeah, it's double displacement. Yeah, because we are essentially switching these two things here. So double displacement. Okay, so our salt in this case is salt that we're used to, table salt, but it doesn't always have to be. And then we get water as well. So because we got a salt and a water, we can assume that we have an acid-base reaction. And we do. Okay, so in an acid-base neutralization reaction, we always have one H plus ion reacting with one OH minus ion or one hydroxide ion. Okay, and you'll see this term strong acid and strong base. What that means, and we're not going to get too far into the weeds in it. We'll save that for later. But basically, a strong acid and a strong base, that means that those ions completely dissociate in water. So we get an H plus completely dissociating from your Cl minus, and our Na plus completely dissociating from our OH minus. And again, we're not going to get too far into the weeds on that yet. But I just wanted you to, if you were looking at that and thinking, what the heck is a strong acid, strong base? That's kind of the basic definition. So, no pun intended. Okay, so if we write the strong acid and strong base as ions, we see that H plus reacts with OH, right? H plus reacts with OH to give what? Yeah, H2O, water. Yeah, that's the only place we see H's and O's anymore. And then our NaCl is the salt that we make. Okay, so just like we did in our precipitation reaction video, we can write the ionic equation. So what's actually reacting in this equation? Well, because we've written out that ionic equation, we can see what ions are the same on both sides and what's actually reacted to form a compound. Okay, so in this case, we can cancel out, right? We're canceling out all of the things that are the same on the left and the right side of the equation. So here's our arrow kind of hidden here. But on the left side, we have our chlorine ion, and we still have it on the right, so we can cross that out. On the left side, we have our Na+, and we still have that on the right. It didn't react. But what did react is we have those H+ ions with those OH- ions reacting to give us water, liquid water. Yeah. So again, just like with our precipitation reactions, that's kind of the part that we're more concerned with. And so we're going to write a net ionic equation so that we can actually see, oh, this is what the two things that are really reacting. Okay, that H+ from the acid and that OH- from the water. Sorry, from the base to form water. So that's our net ionic equation. So how do we balance neutralization reactions? So just like we learned how to write and balance precipitation reactions, we can learn how to do that with acid-base neutralization reactions. So in this case, now we have this base, which is what? Yeah, magnesium hydroxide. And this acid, which is what? Yeah, nitric acid. Okay, and they're reacting to give us salt and water. Okay, so what's giving us water? Well, that's this hydrogen bonding with that OH, right? So that's giving us that water there. So what is actually happening is our magnesium and our hydrogen are switching places, right? Those are our cations, and they're switching places. So our cations are going to switch places, and then we're going to be left with this new salt. Remember, our salt can be something other than NaCl. So in this case, our salt is our ionic compound that doesn't have OH- or H+ in it. In other words, everything that's left over besides water. So in this case, we have magnesium bonded to, what's that NO3 there? Yeah, nitrate. Okay. So you write that salt from the remaining ions and you have your water. The last step is, of course, to balance it, right? So you got to make sure that you have your coefficients there. Okay, so let's actually try this one on our own, especially since they gave us lots of room. So now we have our base, which is which one? Yep, the one with OH- in it. And we have HBr, which is what? That's our acid, and it's hydrobromic acid, right? So let's go ahead and name this. This is magnesium hydroxide. I guess we'll put it down here. Hydroxide. And this is hydrobromic acid. Okay, how did I know that was the acid? Well, that's got that H. And I knew this one was the base because it has that OH-. Okay, so what's going to happen? Remember, this is a double displacement reaction. So we're going to have our Mg and our H switch. Okay, so now our H is going to be bonded with what? Yeah, OH. Watch this. What is H with OH? What's another way of writing that? Yeah, H2O. Yeah. Yep, it's the same thing, right? You got two H's and one O. So let's just go ahead and write that H2O. What form is our H2O going to take? It's going to be a liquid. Because we know in a neutralization reaction, we're always going to get out that liquid water. Okay. All right, so we have our H2O as a liquid. And then we have, and I'm leaving some space for our balanced, for our coefficients. And then we have Mg. And what's our other one? Br. Okay, we need to make sure, I don't see any subscripts under here. And that's because I just smushed together magnesium and bromine because I knew that they were going to bond. But I need to know what ratio they bond in. What formula do they make when they make a compound? So bromine has what ion does bromine form? Yeah, 1-. What about magnesium? Yeah, 2+. So how many bromines do I need to balance out that magnesium? Yeah, I need one more bromine. Yeah, one more bromine for a total of 2. And the reason for that is that if I have 2 negatives on that bromine, or 2 positives on that magnesium, I need 2 negatives on that bromine. Okay, and then let me just scoot this a little closer because it's kind of far. There we go. Okay, so that is our formula. So MgBr2. All right, and what form is that? That's aqueous. Oh, I don't know why I did that. That's aqueous, okay? Because our Mg ions and our bromine ions are kind of just floating around in solution. Remember, they're not participating in the reaction. Just like up here, we could draw the full ionic equation and the net ionic equation. And our net ionic equation for that neutralization reaction would look just like this. Okay, because our magnesium ions would kind of be like this, and our, what's the other one? Bromine ions would kind of be like this. They'd have different charges, but yeah. Okay, so we know we make MgBr2 and H2O, and now we got to figure out how much of each one we make. So let's go ahead and get some more room here. Okay, so let's go ahead and balance this. So we have Mg, O, we have H's, and we have Brs. Why didn't I leave my O's and H's together? Yeah, it's kind of hard because we have O's and H's here, and we have an H here. We also have our O's and H's over here, so they kind of break up. So this would be a case where you don't really want to leave it together, okay? Okay, so I have magnesiums, I have oxygens, I have hydrogens, and I have bromines. So on the other side, I better have magnesiums, I better have some oxygens, I better have hydrogen, and I better have bromine. And I do. So how many of each do I have, though? Let's see. All right, so I'm going to put an imaginary 1 in front of all of these right now. And let's see. So right now I have on the left side, I have 1 magnesium. Okay, that 2 here is going to the O and the H, right? I have 2 OH minuses. So I have 2 O's and 2 H's. That's kind of a weird 2. And 2 H's. Oh, and I forgot this other H, right? I can't forget that other H. Do I multiply that H by these H's? No, I add them. It's another H. So in other words, I have 2 OHs over here and 1 H plus over here. So I have 2 H's here and 1 H here. We can't multiply them because that would make it look like I only had 2 H's. I have 3, so we have to add them. Okay, so that's going to be 3 hydrogens. All right, and then how many bromines? Yeah, just 1. Just 1. Okay, on the right side, I've got how many magnesiums? I got 1 magnesium. How many oxygens? Just 1 right now. I got 2 hydrogens, and I got 2 bromines. All right, so how are we going to balance this? I could make this a 2. Let's try that. Let's make this 2. And we will, that throws off our hydrogens, right? So that gives us 4 hydrogens on the right, and it gives us 2 oxygens on the right. Okay. Okay, well, what if we make this one here a 2? Okay, that helps our bromines out. Now we have 2 bromines. And it changes our hydrogens, but that's okay. So we have, how many hydrogens on this? We got 2 there. And we have 2 here. So that's weird. That actually throws this off. Whoops. 2, 4. Oh, lovely. So, all right. And now that 2 on that HBr on the left there really helped us out, and we actually balanced the whole equation. So that's how you write and balance equations for these acid-base neutralization reactions. I'll see you in the next video, which is going to be all about redox reactions.